Hey guys, now that you have gotten a chance to complete the review problems on your own, let me give you the answers to make sure you are doing it correctly and you are on the right track. So, if you remember to find the domain of any rational function or any function with a fraction, we just take its denominator, we set it equal to 0, we solve for x. In this case, I'm just moving the 3 on the other side, so now it makes it negative. So the domain of part A is all real numbers that can never ever be -3. So this is the only answer that's acceptable. Number 2, again, I would take the denominator and set it equal to 0. I will try to solve for x. What's going to happen is I will now attempt to take the fourth root on both sides. The problem is this now. I have a negative under a square root or a fourth root or a sixth root. That is not possible, okay? So since I do not have any number to exclude, the domain of this is all reals, okay? And if you think about it, it's sort of logic because this, x to the fourth, okay? Any number you plug in, whether it's positive or negative, okay? I'm gonna pick a negative number here, or I can pick positive number. What's happening is when you're raising it to the fourth root, whether it's negative or positive, it will always be, the outcome will always be positive. And if it's a positive already and you're adding it to 2, then that's even a bigger positive. So that's why the denominator can never ever be 0, okay? Last one, I'm gonna take my denominator and I will set it equals to 0. Well, factor the 3, that is never ever going to be 0, so that's ignored. This one, this factor, looks like I have to kind of factor some more, right? So it's going to be an x plus 2 twice. Well, I'm going to take each factor since they are identical. I don't need to do it 2 times. So as you can see, when I solve for x, x is just going to be -2. So for this one, it's going to be all real numbers, except when x is -2. So that's your domain. Okay, so hopefully you guys got the same answers. Next, this is what's really new for us. New for some of us. Find the vertical, horizontal, and or oblique asymptotes, if any. So the first thing is we're going to try to find the vertical asymptote. And the vertical asymptote is exactly the same as the technique or the process is exactly the same as looking for the domain, okay? You take the denominator and you set it equals, you take the denominator and you set it equal to 0 and you solve for x. In this case, the vertical asymptote is x equals to -3. But look, see how when you write it as domain, we exclude it. But because what we exclude in the domain, it is now called a vertical asymptote. They are totally related, okay? Now, you have to pick whether this is an HA, which stands for horizontal asymptote, or an OA, which stands for oblique asymptote. You cannot have both. You have to pick. And how do we pick, okay? If the degree on the top, so when do we know we have an OA? If the degree, can't spell degree. If the degree on numerator is bigger than the degree on denominator, that means then you have an OA, okay? If this is not true, then everything else is an HA, okay? So OA only exists if the degree on top is bigger. So the degree on the top is 2. The degree on the bottom is 1. So for this problem, I'm going to box up OA. And how do you find OA? Well, you're gonna have to do long division. Are you ready? So OA, y equals, get ready to box it up, okay? This is where I'm going to write my answer. Make my hockey stick, On the top, I have 5x squared. On the bottom, you might want to write it just like that, okay? Remember, x plus 3 is not a factor, so you don't expect the remainder to be 0, just to kind of remind you, okay? Well, I'm kind of missing a few terms here, so I'm going to go in and add in my placeholder, which is 0x and a 0 constant, okay? Yes, important, you have to put 0 constant. So, when I take 5x squared divided by x, I now get 5x. I'm going to multiply back and change the sign. So 5x times x is positive 5x squared, but I need to change it to negative 5x squared. 5x times 3 is 15x, but I need to change the sign to negative 15x. When I go and cancel, that is now gone. So now I have negative 15x, bring down my 0. Negative 15x divided by x is now just negative 15. Multiply it back. Negative 15 times x is negative 15. Change my sign to positive 15. Negative 15 times 3 is a negative 45. Change the sign to now positive 45. So my remainder is 45. Okay, and what do you do with the remainder? Well, just like what you did back then when you were in 4th grade and doing the long division. So we have an answer of 5x minus 15 plus a remainder of 45. And you write the remainder over your divisor. But if you remember the definition, right? As we assume that x gets really, really big, okay? Let's say x get to be like 100 or even 1000, either the positive direction or negative direction. This remainder, it's like 45 divided by 1003, right? Well, is that really, really big or really small? Really small, close to 0. So what's happening is we always just ignore the remainder. That's right, we just ignore the remainder. So when we write the oblique asymptote class, you will always ignore the remainder. So your oblique asymptote is a line with a slope of 5 over 1 and a y-intercept at negative 15. And yes, that is how you find your oblique asymptote. Okay? B, let me draw a line because I have a tendency to not be very neat. Okay. First, we would have to take our denominator, set equal to 0 to find my VA. Okay? So my VA, take my denominator, set equal to 0. The two factors are, yes, and I do expect you to be able to factor it fairly quickly. So x plus 4 equals to 0. X plus 1 equals to 0. So my two VAs are x at negative 4 and at x at negative 1. Yes, you can have multiple VAs, okay? Now, how do I determine whether I'm going to have an HA or an OA? Okay, question mark. You would need to look at the degree. The degree on the top is 1, and the degree on the bottom is 2. So currently, the degree on top is not, okay, is not bigger than the degree on the bottom. So this is going to be an HA. And just like an OA, an HA, it's also an equation of a form of a line, just easier. And an HA is a lot easier to find. To do an HA, you just have to take the power function of the top. Okay, so the top has a power function of x. The bottom has a power function of an x squared. So just these two things right here. Well, in math, you have to simplify, right? X divided by x is 1 over x. Okay, and just like the remainder that we did in part A, we are going to assume x approaches some ginormous number. Okay, let's pretend that x approaches like 1000 again, either positive or negative. So what does this really mean? Well, x, 1 over x, or in this case, if I'm letting it be 1000, it's a really, really small number, close to 0. So because it is a line, okay, so we have to make it equal to 0. So 1 over x, it's always going to reduce to 0. So this HA is y equals to 0. Okay, 1 over x, because x approaches a really big number. we are going to now say that this has an asymptote, the horizontal asymptote to be exact, at 0. Okay? Next, this is our last one of today. And yes, after this, you are free, okay, to do whatever you want. So we are going to look for VAs again. Okay? But before we do that, this is slightly unique. Okay? Before we go and look for VA, I would like for you to factor out the top and bottom. So on the top, I have an x plus 2 times an x plus 1. On the bottom, I have an x plus 2 times an x minus 2, because the difference 2 squared. Okay, so this is a unique situation here. Before you can find your VA class, before looking for VAs, factor first, factor and checked to see if the function can cancel. Okay, in this case it does cancel. Okay, so your function, this g of x here, is now reduced down to just this. Okay, what does that, why do we cancel it, right? Well, we cancel it because we want to simplify, we want to reduce. Well, what happened to the x plus 2? Where does it go? Okay, because we cancel the x plus 2, this actually creates a hole. Okay, creates a hole. We will talk about this much later, but right now, this is not an asymptote. Okay, so because we reduce, there's only one denominator now, okay, which is x minus 2 equals to 0. So the only VA that is applicable is now x equals to positive 2 once you're done solving. Okay, and yes, you do use the reduce function to find the VA and all asymptote really. So now let's decide whether this is an OA or an OA or HA. Okay, so HA or OA question mark. Okay, so well, the degree on the top is 1, the degree on the bottom is also 1. So this is definitely HA because the degree on the top is not bigger than the degree on the bottom. Okay, so I'm going to repeat. You only have an oblique asymptote when the degree on the top is bigger. Okay, so let's write the equation. Y equals, the power function on the top is x. The power function on the bottom is also x. Yes, you must reduce. X divided by x is 1. So this one has an oblique, an horizontal asymptote at y equals to 1. And I know, this is not the video you were looking for or the movies you're looking for, but I'm going to give you a break and just end the day right here.